Hello and welcome to our Advanced Computer Engineering project, which revolves around the design and creation of a home automation system. I will now pass you on to Andre, who will discuss the initial brainstorming phase of the project.
Hello, my name is Andre Moses and I'll be speaking about the different ideas we had in regards to the project using the Odroid. The first idea we kind of came up with was to promote the uni in fitness way, connecting the Odroid to the badminton to monitor performance. We had some other ideas in regards to using robotics, using the Odroid to perform different kind of actions in regards to using lighting, and also we had an idea that expanded on data collection. And as you can see here, that would have included a touchscreen interface as well as using an accelerometer and the GPS and other little functions that the Odroid would feature in. We had a surveillance idea where the Odroid would be connected to a camera to survey a specific area that has been pointed at. And we came up with other ideas using the Odroid and a Raspberry Pi 3 to connect them together to be able to perform different kind of functions that we decided to use. We finally decided to use a homebought idea which will be further explained in this presentation.
We aim to implement a system that works across the network to control devices using voice. This voice control will allow us to control music, lights and cameras, all located on the network. Open source packages were implemented and downloaded to then be modified to allow us to use the features that we designed. Unfortunately, the team were unsuccessful in implementing this voice control recognition system. This is due to the problems that arise when trying to implement the related technologies. One of the solutions to implementing voice control was Jasper. Jasper is an open source voice control system built and designed specifically for Raspberry Pi. The team had problems implementing Jasper due to its complexities. Python routinely crashed when trying to load the program on initial launch. Ubuntu voice control was also looked into, but during the research phase it was found out that the program could not be modified and new commands couldn't be added. This meant the team could not implement the features discussed in the design phase. Also, Amazon Echo was looked into as a solution to our problem. But during the implementation of this system we found out it needed too many resources and ran too slowly to be effective. Simon was also looked into as a solution, but unfortunately we couldn't get our microphone to be recognised by the system. After trying to implement these programs, it was clear that voice control is tricky to implement on a Linux-based system. Instead, the team decided to look into web-based technologies to find a solution. After struggling with voice control technologies, the team decided to move on to a more web-based home automation system. This system will include a website which scans the network for camera feeds. When a camera is found, the website will show a live feed. The system will store images when motion is detected. These images can then be later viewed on the website. This website will be hosted on one Odroid using Apache and will feature a login system. Next, Alex will now take you through how the network was designed and implemented.
So for our project we have 3 Odroids, 1, 2 and 3 over there. We've got set up an ad hoc network on all 3. So what that means is not one of them is a core device, so each has to forward their own packets to each device over the network, and as this is a wireless network, each Odroid is able to communicate to each other Odroid simultaneously. The problems, we had one issue dealing with the ad hoc network, was that there was a fail configuration within our interfaces file. So what we had to do is use the GUI side of it, and on all 3 of the Odroids, which allowed us to run the ad hoc network.
Hello there. This is the website we've created for our HomeBot automated system. So this is the first page that the user will see when they first go to our website. Here you will see the website we created with HTML and CSS. Here we just have some basic images that sort of show the main features of the system, obviously running on Linux, and the way that we can control cameras and view past camera feeds. Here you can see we've used the CSS to create a coherent theme throughout the website. We've used blue colours and we've used that to create our logo. So here on the top right of the website, this is where you obviously log into the system with your own username and password. And of course, if you haven't got one of these, I'm going to show you how you can register with the page. So obviously you click on the register tab at the top right of the corner. Here you'll be greeted to a new page where you can type in your information. So my name's Nathan, username phonebot, and password, which is very insecure. But so you just press the submit button and it will automatically log you in with the details you've provided. So when you return to the home screen, you'll see that it's now put your name that you've predefined on top of the screen and that you've logged in, so you now have access to the rest of the website.
Hi, I'm Luke and I'm going to be talking about the camera system in the project. For our project there was two main things we wanted the camera to do, and that's A, be able to store images in a certain directory, images that have been detected via motion, and B, to be able to produce a live stream that we could access on a different system, or in this case the Odroid. For us there was only one package that did this, and that was called Motion. And Motion lets you detect any sort of motion in front of the camera. It will store images at a certain rate to a directory, and we would like to use this to then show these images on a website. And again, we'd also like to so that it records continuous footage, so that this feed can also be viewed on the website as well. I'm going to talk about the live streaming aspect of the project and how that works. So here we've got the configuration file, and with numerous things we have to specify here, including the ports that the service is going to listen on, the quality of the stream, and the maximum frame rate of the video as well. And this, you know, you're not going to likely hit 60. The higher the better here. And we've also got a feature called Stream Motion, and what this does is it makes it so when there's no motion being detected, the camera only films at 1 frame per second. But at the moment there's motion happening, it jumps to a full 60. Now if I go over here into the terminal and start the service, so motion is now running on the camera, which is set up here. And if we go over to our main Odroid onto the website that we were on earlier, you should be able to click on My Camera and view the feed. It's currently live. Now if we make this point on a static object, it should motion should kick in and it should jump down to 1 frame per second. We've got a timestamp here that can show this feature. As you can see now, it's going up at a very slower rate. At the moment motion is detected. Ooh. It kicks in at a full frame rate. Now in the final version there will be 2 cameras set up, but for now just the one, but it will follow the exact same procedure. Now we're going to demonstrate the dual live screen feature. Here's one Odroid connected up to a webcam, and over here is a second Odroid connecting up to a second webcam. And on the website, if we click on My Camera, it should show both live streams. So if we could bring in the subject to test motion. One might lag a bit. What you can see here is the conference file for Motion, which lets you edit all the settings. And here we've edited the target directory for saving images to be the central Odroid's images file. There are currently 5 images there, as you can see on 1.1. And if we go over to the website here, picking up from where we left off, we're now signed in, and we should be able to click on My Pictures. And here it displays those 5 images dynamically using the PHP code. So it picks up all the images in that directory and puts them out to the screen.
Taking a look at the feasibility of the project, this stage focused on determining whether the idea of a homebot was achievable. This included looking at standard elements, suitable software and hardware that could be compatible and also accessible. After ensuring that the project idea was feasible, the requirements and specifications of the bot were analysed, certifying what the system is expected to do as well as how it was expected to perform using the standard elements featured. With referral to the requirements of the homebot, the design stages involved experimenting with various software packages concerning voice control, surveillance and sound. The stages of the project then moved on to the implementation, in which the design process had been underway. In terms of networking, a local area network had been designed to serve the purpose of video surveillance and storing images. The homebot was then to be tested against the requirements gathered at the early stages of the project to assess if the functionality of the system worked as it was intended to. Finally, the project was concluded evaluating the successes and inconveniences in addition to resolutions and possible plans for the future.
There are some more ideas we'd like to work on if we had more time. One of those being the potential to look at past broadcasts on the website as opposed to just the images that it is now. That way we'd be able to look at some stored video files. Also we'd like to look at maybe more features to implement for the website. And we tried to set up the most basic we could to begin with just to make sure things worked, but we could have implemented more on that end as well. Another feature we would have liked to have implemented would have been a notification system, and this would have helped to notify the user maybe when a broadcast was starting or maybe when motion had been detected.
So there were quite a few problems that we ran into when working on the O-Droids. Unfortunately, we kept having to re-image our SD cards because they kept corrupting. We're not too sure why, and that really hindered our process on working on mostly the voice control solutions. Also during the project, we also had a lot of trouble trying to install different packages. Some of the times they were built for Raspberry Pis or other embedded devices, not the O-Droid specifically. So we had a lot of trouble trying to get the right packages to work on our system.
Thank you for watching our presentation, and we hope you enjoyed learning more about the homebot. Wait, alright. You're going to cut it anyway, aren't you?
Yeah.
Okay.
Here you can see on the website that we've used CSS to create a colour scheme throughout the website, and we've used that colour scheme obviously to make the logo, to make it recognisable. So when creating the website, first of all I wanted to create a good theme and logo for the homebot system. This means so it's more recognisable.
I need to go to the Tashi station to pick up some power converter. Are you filming?